Welcome everybody to today's webinar, Fast-Blotting Minigels in 15 minutes. We will start our today's topics with a short overview of the Western blotting workflow. Then we go step by step how to optimize this workflow, how products can help us to blot fast. And at the end, we have a method comparison and a Q2A session. Please use the chat. I will then answer your questions one by another. So this is the Western blotting workflow in a glance. It always begins with a good sample preparation, followed by an electrophoresis. As we talk about Western blotting, it is a polyacrylamide gel electrophoresis. Then the transfer itself, so the transfer of proteins on a membrane. After the blotting, you might process the blot somehow. You can stain, you can do immunoblotting, or any other applications that you do. And it ends with the documentation of your blot, let's say. So we at Serva, we can help, especially in electrophoresis and the blotting transfer, and this is our promise, to shorten down the total time of more than 90 minutes for a standard protocol down to 45 minutes in total. And how we do that, we will see in the next slides. But first of all, we have to talk about a little side topic, electrical parameters. So you see a gel on the left and right side. On the left side, it's the polyacrylamide gel electrophoresis, and on the right side, it is the blotting as application. In electrophoresis, the electrodes are placed on the sides of the gel, and the separation distance is a long way from one end to the other. The separation distance is influenced by the ion flow. And the longer the separation distance is, the longer the ion must flow, the higher the voltage must be. On the other hand, the amperes needed are proportional to the area of the ion flow where the ions can pass in the electric in the electric flow. Thus, the area in centimeters to the square is proportional with the ampere. In page, you need thus a high voltage and a low ampere. When you take a look to the blot, you have switched the electrodes from the sides to the main area, so top and bottom of the gel. So the separation distance is very small, so you need low voltages in blotting. But the area of the ion flow, and in this application in blotting, it is the area of your blotting sandwich or your blot sandwich, also in square centimeters. You need high ampere for this. So the electrical parameters are completely crossed over, let's say. And when you read high, so high voltage, high ampere, this might implicate you that you have maybe a problem if you want to speed it up. Because no matter if you raise the volts or you raise the amperes, the heat that is produced is the product of volts, amperes, and time. So be careful by raising the volts. It might end in a high heat. So this is to be avoided. So let's talk about the gel electrophoresis. Before you do the electrophoresis, you must perhaps cast your own gel. And casting gels are very time consuming. And additionally, all the casters and the chambers on the market need a lot of handling steps. So if you want to speed up, also think about not to cast and use casters and chambers that are less in handling steps or sophisticated clamps, screws, what have you. And also take care that your chamber is leak free, because we want to speed up, we must raise the voltage. So the high voltage leads to high heat. We got that. When we take a look to the standard protocol in Tris glycine buffer system or in MOPS maze buffer system, the so-called new page gels, you apply approximately 100 to 200 volts. And then the separation is finished in, let's say, 30 to 120 minutes. This is quite long, 2 hours. So we at Serva have a solution. First of all, we have our blue vertical prime chamber. On the next slide, I will show you why this might spare time. And we have in our portfolio the so-called Serva gel neutral HSE gels. HSE is the short for high-speed electrophoresis. Of course, you can also use these gels in any other chamber that can load 10 to 10 centimeter gel cassettes. For example, the Hüfer chambers, SE260 300 or the Novex X gel. But it must be a chamber with a dummy plate, because when we raise up the voltage, then we are only performing it with one gel. The heat would be too much with two gels. So take care that you have a dummy plate. So this is our blue vertical prime chamber, and I marked in pink what is special about it. You have no clamps, no screws, or else you simply have two arms that you can flip upwards and press down with the thumbs, and then the gel cassette is already in place, is leak-free sealed, and you are ready to go. So more simple, we do not find anything on the market. And these are our high-speed electrophoresis gels. You can order them with 10, 12, or 15 sample wells or a 2D sample well. Again, use only one gel with a dummy plate in your chamber, and you can raise up to 400 volts. And this will lead to a separation time in about 20 minutes. And you see with the gel picture in the back that you really get a superb resolution here. The good thing is that you simply need a normal Tris glycine running buffer. So no fancy buffer system, or else it's your simple Tris glycine running buffer. The resolution is around 6.5 to 200 kilodaltons. So approximately a Lamley gel or Tris glycine gel of 12%, let's say. Additionally, as it is a special matrix, that is perfect for blotting. So good for us when we want to speed up the blotting procedure. And this is what we can offer here. Due to the high heat with the high amperes that are needed, most other brands demand sophisticated devices with an active cooling. So this is how they do the fast blotting. Additionally, they offer special copper plates and reagents. So you cannot use your own things. You have to buy them from each company itself. And here we have also a solution, a better one, I think, but everybody should decide on it all. We have our normal Blue Blot SD semi-dry blotter. You can, of course, use any other blotter if you like. And the magic is inside the Express blotting kits we have. So just a short look at the Blue Blot semi-dry blotter. We decided to have both electrode plates removable from the base so that you can clean it well. You can use it for any semi-dry application in the life science, and it has a special closing, so the lid, it has a twist to close, and it has a slight pressure on the blot that renders the 2-liter bottle unnecessary. And this is the magic kit. You can have it as a blank version, so without any membrane, a PVDF or an NC version, so the two membranes that are mainly used. And with this kit, you can have a 25 or 20 minutes, depending on the size of the proteins, blot at 400 milliamps. Inside this kit, it's all you need. So you have pre-cut wicks, membranes, and the buffer itself, the express blotting buffer. And the good thing is you don't need any special stacking procedure. So no copper plate in between, no fancy stuff. It is like you know it. So you have a blotting fleece, a connection paper, membrane gel, and again a blotting fleece. The blotting fleece is just a little bit thicker and of a different material, and it simply replaces the three blotting papers you might all use at the moment. And here is the comparison in between the applications. I tried something, so let's see if this works out. We pretend now that we start with the electrophoresis. So out of count is the sample prep. That is most often only 10 minutes long, can last longer if you need to process your sample in any way. And of course, out of count is the gel casting. So when you watched our last webinars, you might have learned that you need at least 12 hours for a complete polymerization of the gel. So of course you can shorten this, but let's take this out of count, then it is simpler to compare. So with our system, so the HSE gels that run 20 minutes, then you need to equilibrate the gel with the blotting buffer. This lasts 10 minutes. And afterwards, you do the fast blotting 400 milliamps, 15 minutes. And this leads to a total time of 45 minutes with the Serva fast blotting procedure. Let's compare it with the standard protocol. So a standard Lemley gel or trisglycin gel and the normal blotting procedure with normal buffers, let's say. The electrophoresis with trisglycin gels is approximately in the mean 60 minutes and then 45 minutes blotting. And so you can see right away that you have a total time of 105 minutes. So using the Serva procedure, you spare more than half of the time. Of course, you say, well, then just use other gels or so. Yes, we can try this. So let's use the MOPS-MES buffer system or the new page gels or whatever the other competitors call it. They are able to be run in 30 minutes. And then presume that you have a normal blotting procedure of 45 minutes, just like with the classical glycine procedure. And then you are in total of 75 minutes. So the Serva blotting procedure is even faster. Okay, you might say, then shorten this down a little bit more. We can use these sophisticated devices from other companies. Yes, we can try this. And we use again the MOPS gels or the MOPS buffered gels for 30 minutes. It's the shortest that I know from our competitors. And then such a sophisticated fast blotting device of a blotting capacity of about 10 minutes. So it's 5 to 10 minutes in their manuals. So you would be faster, but only 5 minutes. And you have a special device board with special buffers and so on. So yeah, here you see that with Serva you can use your devices that might be in your lab already. You just simply need to buy our Express Blotting Kit and watch this webinar again, and you can really screw the time down to 45 minutes without any special device, special buffer or else. So that was it for today.